Hey everyone, so welcome back to my YouTube channel where we discuss complex topics in a simple and logical way. So in last lesson we were discussing the homogeneous differential equations. So today we will start with the non-homogeneous differential equations. So we saw that in homogeneous differential equation you can bring down this m dx plus n xy type of differential equation to this form, that is dy by dx as a function of f y by x. But in case of non-homogeneous differential equation you cannot do so. So if you see a special type of this non-homogeneous differential equation, then this is the case where the function m xy and n xy is a linear equation. So we will see different cases about it. So for example, this m xy, this function is a linear equation of this form, and the other function n xy is a linear equation of the second form. So if you see this, so the differential equation can be brought in this way. So dy by dx is equal to this first linear equation divided by second linear equation. But here you can see that we are not able to express this in form of function of y divided by x. So this is not a homogeneous equation. So it is a non-homogeneous equation. So we will see two different cases to solve this type of non-homogeneous equations, where we will have numerator and denominator both are linear equations. So the first case is, which we will discuss in this video, is these are parallel lines. These numerator and denominator linear equation are parallel line. So for that the condition is a by a1 is equal to b by b1. So we know that in case of parallel line the slopes are equal. So here the condition should be a by a1 is equal to b by b1. And here we will apply the variable separable method which we saw earlier, and substitute this ax plus by is equal to t. And we will see and discuss, we will take an illustration as well as we will discuss a problem also. And in the next class we will discuss the second case of this type of differential equation, where we will see the numerator and denominator are non-parallel lines. So what does it mean? So here the slope of the lines are not equal, like a by a1 is not equal to b by b1. So here we will apply the homogeneous method, and we will see more about it in the next video. So in this video we have to focus more about this type of parallel lines type of differential equation, non-homogeneous differential equation. So let's see the first case in detail now. So I already told you that the slopes of these parallel lines should be equal. So for example, let's take an illustration. So this is an illustration of the differential equation we are talking about. So you can rearrange this equation in this form: dy by dx is equal to this line equation and this line equation. So if you see, first check that whether it is a parallel line or not. So here we will divide this a1 by a2 and b1 by b2, and we will see. So here we will see that 1 by 2 and here also 1 by 2. So it is equal. It means these are parallel lines. So what you have to do now in the next step, just take out the 2 common from the denominator. So you can see that we have taken out the 2 common. Now this part is common in numerator as well as denominator. So just substitute it with t. So now we will differentiate this with respect to x. So for example, here we have differentiated with respect to x. It will become 2. This will become 3 dy by dx, and this will become dt by dx. Then further rearranging so what you will do is we will substitute this in this parent equation. So now you will get this after substituting in the parent equation. So here you can see that further you will bring this 1 by 3 in this side and multiply it, and you will bring this -2 and add it in the RHS side. So you will get this. So finally when you solve it, so here you see that you will get a function of t, and you can apply the variable separable method easily. So you can bring this function of t in the side of dt and the dx on the other side, and you can separately integrate with respect to t and with respect to x. So in this next class step you can see that this is the function of t which we have formed, and with respect to dt we can easily integrate, and the dx also we can integrate on the other side. And finally if you see, so here you can split the numerator in 2 terms. We will see how in the problem. So if you split the numerator, and then you can see that you can further integrate this. So on integration you will find this. So this was the main thing. So we will see one problem, and we will see a similar question on this. So if you see this problem, so I hope that you have understood the concept And now I would like to like you all to pause the video and try this problem by yourself, and after like 1 second I will solve this problem. Okay, so now let's solve this problem. So what you can see here, you can again bring out 2 common from here. So like further, if you see dy by dx, you can write x plus 1, and here we have seen that we will bring out 2 from the denominator. So here you can substitute this x plus y as t. Okay, so like differentiate this further. With respect to x, we will get this 1 plus dy by dx is equal to dt by dx. Now like substitute in the parent equation. So in place of dy by dx, you can write this like from this equation. So dy by dx will become dt by dx minus 1. On RHS side, this will become t plus 1 by 2t plus 3. So you can see from here, so it will become t plus 1 divided by 2t plus 3. Now let's take this on the RHS side. So dt by dx will become t plus 1 by 2t plus 3 plus 1. So adding this, you will get 2t plus 3, and on the numerator you will get 2t plus 3 dt by dx. So further, if you see, so I'm just following all the steps so that you can understand it. So you will get 3t plus 4. Now you can see that this is a function of t, and you can apply differentiate like variable separable, so you can bring this on the side of dt. So you will get 2t plus 3 divided by 3t plus 4, and you have to and dx will come this side, so you can integrate both sides. So here it is very simple. You will get x plus c, and this we have to integrate. So what we will do is, first we will split this numerator. So in this lesson also I have told you how I will show you in the problem how I will split the numerator. So what you can do is, you can simply divide it, 3t plus 4, and in numerator we had 2t plus 3. So you have to divide it by multiply by 2 by 3. So if you see, when we multiply by 2 by 3, you will get 2t plus 4 into 2, 8 by 3. So just minus it, so you will get this cancelled, and here you will get 3 minus 8 by 3 as 1 by 3. So you can split this, okay, and you can write it like integration of 3t plus 4 into 1 by 3 plus 2 by 3, and in denominator we had 3t plus 4, and you have to integrate with respect to dt. So further, if you integrate this, so you will get like this will become 1 by 3, and this will become 2 by 3 3t plus 4 and dt, and on the RHS we saw x plus c was there. So further you will get t by 3 over here, then 2 by 3 ln 3t plus 4, and also because here you are having 3, so 1 by 3 will come in denominator. So here finally we get t by 3 plus 2 by 9 ln 3t plus 4 is equal to x plus c. So here you can replace the t that we saw with x plus y. So this is our final equation. So you just need to replace the t with x plus y, and your job is done.